Hi, welcome to FlyBy. Today we're here with visualization specialist at the Harvard-Smithsonian Center for Astrophysics, Joe DePasquale. Joe, welcome to FlyBy.
Thanks, Chris. Thanks for bringing me in here.
So when there's a press release, when NASA comes out with a new finding or new images, essentially you're taking data to create an image to be a part of that press release.
You know, in general, the public's perception of how these images are created, people tend to think it's like a camera, right? You just shoot a picture and there it is. But with astronomy, it's very different. What we get from the telescopes is just data. And in most cases, it's just a black and white image with a lot of artifacts and it's a really messy thing that needs to be cleaned up. It has to have color applied to it. We're not inventing color when we do this, but we do have to make decisions about how to color the images.
You're actually taking data and then you're applying color to it, but there's not necessarily rules and guidelines, traditionally speaking, with how best to apply color. But you mentioned there's certain rules with regards to heat that you take a look at that informs how to color images.
Yeah, so my group at the observatory has been involved in the past few years with a project called Aesthetics in Astronomy, where we've been interviewing the general public and giving them surveys to see what their perceptions of astronomical images are, how they interpret the colors that are used in those images and what it means to them. And one of the things we found that's really interesting is, say for example, you do a Google search for cool colors, cold things, like what would you expect to find?
Generally things blue, light blue, dark blue.
Right. So that's like a culturally conditioned thing.
Sure.
That people expect cool things to be bluish and warm things to be red or yellow. And in physics, that's actually the opposite. Hot things they get bluer and bluer and bluer till they get to white. And as you cool them off, they turn redder in color. So we try to use that information. We know that people have this perception of what colors mean, but we also want to stay true to the physics of the objects that we're looking at. And so I typically choose cooler colors for X-ray in these images.
The building blocks of your story is data, like ones and zeros.
That's right.
But how do ones and zeros become something that we're looking up, up here on the board?
Well, it depends on the type of telescope you're working with, but with X-rays, for example, the Chandra X-ray Observatory has these amazing mirrors that can focus X-rays with such high precision. It has these exquisite mirrors. They're actually very different. The technology to focus X-rays is very different from any other telescope technology. It's essentially barrels, glass barrels. Instead of being like a big mirror, these barrels do something called grazing incidence, where X-rays come in and they bounce off the mirror, almost like skipping a stone on a pond. And then they're guided down this long, it's called the optical bench, to the detectors. And that where the detectors are, they're sensitive to X-rays. They're just CCDs, like in a cell phone camera. Mm-hmm. So they have CCDs in them that then take that data. It takes readings of X-ray light. An X-ray photon hits the detector. We know the energy of that photon, where it struck the detector, when it hit the detector. And all this information then gets transmitted to the ground. And we can reconstruct an image from that data.